Now our figure 15-9 from Stallcup's electrical design book, volume 2, excuse me, we pick up sizing the equipment grounding conductor when we have a voltage drop problem. Now you notice in the quick calc in the illustration, we have 140 amps as the connected load. It's continuous, so we multiply by 125%, we come up with 175. Referencing our table 310.16, we pick up a 2-aught, good for 175, and we put that on a 175 amp main, and that circuit is completely protected. But we have a voltage drop problem. So we raise it up to 3-aught and connect the 3-aught to the 175 amp main. Now we can start determining if we need to increase that equipment ground or not. Step 1, we apply 250.122B as in boy and table 250.122, meaning that the 175 overcurrent device requires the number 6 equipment ground per table 250.122 in step 1. Step 2, table 310.16, 175 amp load, we selected a 2-aught conductor from table 310.16. But due to voltage drop, we increase from 2-aught to 3-aught. Now in step 3, we apply 250.122B as well as table 8 to chapter 9. And a 2-aught has 133,100 circular mil rating from table 8, chapter 9. The 3-aught has 167,800 from table 8, chapter 9. Now the number 6, the original size based upon the 175 amp main was a number 6. And its circular mil rating is 26,240 that we have to compare to when we do our math. So in step 4, we take the 167,800 3-aught circular mil rating, divide it by the 2-aught circular mil rating of 133,100, and there's our multiplier, 1.2607062. Step 5, we take the original equipment grounding conductor's circular mil rating in step 3 based upon the 175 amp main, number 6, 26,240, multiply it by the multiplier of step 4, 1.2607062. The equipment ground is 33,081 circular mil. Yeah, that's greater than the number 6 in step 3. It's just 26,240. So it has to be raised to a number 4, selected from table 8 to chapter 9 in the back of the NEC, which would give you 41,470 circular mil for number 4. So we would increase it to number 4. And then you go to article or section 220.61, and you see if that neutral was large enough and complied with 220.61 to supply the neutral load. But if it didn't, then you may have to raise your neutral up to whatever size it would take to comply with 220.61 when you run your calculation for neutral load. And that's what this figure 15-9 is illustrating.